In this video, I am going to make the effort to help you understand angle relationships. And in the first type of angle relationship are these parallel lines that are cut by a transversal. And you can see that that creates 4 angles at each intersection point. Sometimes those angles are congruent, that is, they are equal to each other. And in other instances they are supplementary, and that means that the angles add up to 180 degrees. The rule of thumb in 8th grade math for this kind of diagram is that if they look the same, then they are the same. So I'm going to show you here in pink. Those 2 angles are congruent. They look about the same size. The arc that connects one to the next is about the same size, so they are the same. These are also congruent. These 2 are congruent, that is, this corner and this corner are equal to each other. This corner and this corner are equal to each other. These opposite corners are equal to each other. These opposite corners are equal to each other. And this one down here in the lower left and this one up here in the upper right are equal to each other. The larger of the 2 angles also have a similar relationship. These 2 angles are congruent, that is, they are equal to each other. These 2 are congruent, equal to each other. These 2 green arcs right here are equal. These 2 are equal. These 2 on the insides are equal. And these 2 on the opposite outsides are equal. So I'm going to number the angles. 1, 2, 3, 4, 5, 6, 7, and 8. And then I'm going to come over here and write all the pairs of angles that are congruent. 1 and 4 are congruent. So angle 1 is congruent to angle 4. 5 and 8. Angle 5 is congruent to angle 8. 1 is congruent to 5 here. Angle 4 is congruent to angle 8. And then we have the pink segments. Angle 2 is congruent to angle 3. Angle 6 is congruent to angle 7. Angle 3 is congruent to angle 7. And angle 2 is congruent to angle 6. We could keep going. 7 is congruent to 2. 3 is congruent to 6. So angle 2 is congruent to angle 7. Angle 3 is congruent to angle 6. And there's 2 others on the green. 5 is congruent to 4. 1 is congruent to 8. Those are the pairs of congruent angles. Now let's look at the angles that are supplementary, that add up to 180 degrees. Well, any combination of green and pink is going to make one straight line or one straight angle. So that's going to add up to 180 degrees. Angle 6 plus angle 8, for example, these 2 right here are supplementary, so they add to 180 degrees. 7 and 5 are also supplementary. 7 and 8, 5 and 6, 1 and 3, 2 and 4, 1 and 2, 3 and 4. Anywhere you have angles that make a straight line, you have supplementary angles. The tricky ones, the ones that you need to look closely for, are say 6 and 4. I have a pink segment and I have a green segment. So angle 6 plus angle 4 is going to supplement to 180 degrees. Same thing on the outside. Angle 8 and angle 2, those could supplement each other to equal 180 degrees. The next set of angle relationships we want to look at come from the interior and the exterior angles of a triangle. Here are the interior angles, the ones on the inside, and we have this one on the outside that's an exterior angle. Now, we should know from previous experience that the three angles inside of a triangle will always add up to 180 degrees. And also that any two angles on a straight line will add up to 180 degrees. So we can use that to discover a very interesting property. Angle 1 plus angle 2 plus angle 3 should equal 180 degrees. Angle 3 plus angle 4, because they make a straight line, should also equal 180 degrees. So if these three equal 180 and these two, when added together, equal 180, then these three should equal these two. The three interior angles, when added together, are the same as this interior angle and that exterior angle added together. We can create a zero pair by subtracting angle 3 from both sides, bringing the equal sign straight down the way we do when we always solve. Angle 4 is all that's left on the right hand side. Angle 1 plus angle 2 are all that's left on the left hand side. And we have done a little proof here that shows that these two angles will always add together to equal this angle on the outside.